How our universe was born. If this is difficult to answer, then how about this question? What was there before our universe? While scientists are looking for an answer to the most difficult question in history, let's find out what they finally came to. In the 20th century, a great man shed light on this mystery. Edwin Hubble. Once upon a time on Mount Wilson in the South California, he pointed his telescope at the sky and discovered that the clouds of gas that fly everywhere there are actually other galaxies, and there are a lot of them there, and he also learned something that changed the world forever. They are moving. So what, you ask, but this meant one very important thing. The universe is expanding, and if it is expanding, that means it all started somewhere, right? All that remains is to start the time to sleep and see. Why exactly? It took scientists many more years to develop a full-fledged theory, the Big Bang Theory. Something reigned everywhere and there were no concepts of when or where. There was only a cosmic singularity. This is the state of our universe in which it was incredibly small, dense, and very hot. Imagine that our universe was compressed into a small ball. The pressure and temperature inside were enormous. At some point it became impossible to resist this and a big explosion occurred. The release of energy and matter of tectonic force, which created everything that we now see, time and space, basic physical forces and quarks. Quarks, the tiny particles that make up our world, were boiling in the hot cosmic soup. As it cooled down, gravity began to pull them towards each other. They assembled into atoms, then into molecules, and then into the first objects. Stars. And all this happened just some 12 to 14 billion years ago. So now we know how our universe came into being, but what came before it? Alan Harvey Godd, an American theoretical physicist and cosmologist, devoted his entire life to solving this mystery. He discovered some flaws in the Big Bang Theory. For example, the distribution of matter was very uniform, although this should not have been the case. We hang a balloon filled with paint from the ceiling and lay a white canvas on the floor. If you drop this ball, it will burst and there will be absolute chaos on the canvas. A bunch of different spots scattered randomly everywhere, but nothing at all like what the early universe looked like. Instead of throwing a ball, let's draw a small red dot on the canvas. Now let's increase it a little. And a little more. If we capture this with time-lapse photography, we will see a circle gradually growing in all directions. This is the reality. The early universe was smooth and proportional. This was the discovery of Gödel, the theory of inflation. According to it, before the Big Bang, there was some kind of force that could give the explosion a powerful acceleration. Something that instantly and evenly distributed everything in space. The Gödel theory was a great success, and now many scientists build on it. For most of them, this idea of the origin of the universe is quite enough, for most, but not for all. Martin Buwald, a German professor of physics, believes that the universe was born in a completely different way. Remember we talked about the cosmic singularity, that is, about the state of the universe in which it was small, dense, and super hot. According to Buwald's theory, the singularity could not have appeared out of nowhere. This is nonsense, but then how did it appear? Let's take a look at the pendulum of an old clock, which swings left and right. It moves smoothly, continuously, and without stopping. This is how we see time, it flows and does not stop. But quantum time doesn't work like that, it's more like the second hand of a clock. It consists of small segments and makes short pauses, like the second hand of a watch. The beginning of one period of time is always the end of another. Do you understand what this means? Let's go back to balloons again. According to Big Bang theories, once upon a time our universe began to expand, inflate like a balloon, but sooner or later the balloon deflates. The universe will begin to shrink and return to a state of cosmic singularity. And what happens next? Another big explosion. Nothing appears out of nowhere and nothing disappears into nowhere. According to Buwald's theory, the beginning of each universe is the end of the previous one. Our universe is not the first and not the last. Millions of similar universes existed before us and will exist after us. This theory, although it sounds very logical, is far from complete. Unfortunately, we don't have enough knowledge to find all the evidence, so this is just a hypothesis for now. But some scientists come up with even stranger ideas. Sometimes they put forward completely unusual theories. Neil Turok, a South African physicist, and his colleague Paul Steinhardt, an American theoretical physicist, are looking for answers far beyond our universe. They agree that our universe is not the first. There have been and will be an infinite number of them. According to their theory, our universe is just one of an infinite number of others. And we are all stuck in a cycle of endless rebirths of parallel worlds. It sounds strange and scary, but how does it work? According to this theory, our universe is located on a so-called brane, like a membrane. That is, we are stuck on some kind of elastic surface that can compress, stretch, vibrate, and so on. Like pieces of cloth on a rope, these parallel universes are located next to each other. Each of them has a neighbor and we are no exception. Another universe may be a centimeter away from ours, but we cannot see it because there is a fourth-dimensional space between us. How do these universes come into being? Through the collision brane. These branes very slowly get closer to each other until one day they finally collide. This creates two big bangs and two parallel universes. Then they move away from each other. New worlds continue to live. Now we are exactly at this stage, but when they disappear, the branes collide again and this leads to the birth of a new universe. Remember the theory of inflation? Some mysterious energy pushed and accelerated the big explosion. Yes, if we really collided with another universe, that would explain everything. Of course, everything described here is a big simplification. When we hear that our world is a piece of cloth on a string, it sounds stupid. But this idea is based on string theory and M-theory. Two giants of quantum mechanics. If they turn out to be true, they could explain almost everything in our universe. Creating a theory is an incredibly complex process. Turok and Steinhardt did a huge amount of calculations and rejected many theories that didn't work. To figure this out, they had to go beyond the human mind and think in 11 dimensions at once. Unfortunately, this incredible and elegant theory was only laughed at. Turok and Steinhardt say that scientists are ordinary people. They are just like everyone else, they are also afraid of change and the unknown. It's always scary to question everything we believe in. Many years ago, people did not believe that the Earth was round. Then they were outraged by the Big Bang Theory. A discovery cannot be made without struggle and fear. Is this why Turok and Steinhardt are not going to give up? Ultimately, the available evidence suggests that each of the three theories is equally possible. So which one is correct? We may never know. At least in the near future. Unfortunately, for now we can only build theories, but maybe one day we will find something that will open our eyes and we will unravel the mystery of how our universe came into being.